everyone, my name is Irene and I am a science and math tutor here at OpenWisdom Education. In this short video series, we will look at different questions from the 2020 HSC papers, and in this particular video, we will look at questions 4 and 16 from the Chemistry HSC exam. So we're going to start with question 16. This question is from Module 5, which is Equilibrium and Acid Reactions, and it is taken from the dot point that you see on the right-hand side of the screen. Feel free to pause the video and have a go at the question on your own, otherwise we will get started. So let's have a read through the question first. Compounds X, Y, and Z are in equilibrium. The diagram shows the effects of temperature and pressure on the equilibrium yield of compound Z. Which equation would be consistent with this data? First things first, when we answer any question about equilibrium, we need to remember Le Chatelier's principle, which states that when a disturbance is imposed on a system at equilibrium, the system will adjust itself so as to minimize the change. Now, let's look at the graph. We see that as the temperature goes up, the yield of Z also goes up. We also see that as the pressure goes up, so we see that as we go from 10 MPa to 50 MPa, the yield of Z actually goes down. So these are the two observations that we make from the graph. Again, as the temperature increases, the yield of compound Z increases, and as the pressure increases, the yield of compound Z decreases. So now let's try to explain these observations in terms of Le Chatelier's principle. So we saw that as the temperature increases, the yield of compound Z increases, which means that the forward reaction is favored. Now, if the forward reaction is favored, then this signifies that the forward reaction minimizes the disturbance that is imposed on the equilibrium. So, since the disturbance imposed is an increase in temperature, and the forward reaction minimizes that, then that means that the forward reaction is endothermic. So, let's look at the options that we have. We see that option B and option D are exothermic because the change in enthalpy is negative, so we can eliminate these options. As for pressure, we see that as the pressure increases, the yield of compound Z decreases, so the reverse reaction is favored in this case. If the reverse reaction is favored in order to minimize an increase in pressure, then the left-hand side of the reaction, or the reactant side, must have less gas molecules. Let's look at our options again. In option A, we have 1 mole of X on the left-hand side and 3 moles of Y, which makes it 4 moles of gas in total, and we have 2 moles of gas on the right-hand side. So since we have more gases on the left-hand side than on the right-hand side, that means that A has to be wrong. Let's look at C as well. We have 2 moles of gas on the left-hand side, and we also have 3 moles of gas on the right-hand side. So we have more gases on the product side than on the reactant side, so C is correct. We can now move on to question 4. This question comes from Module 8, which is Applying Chemical Ideas, and it relates to infrared spectroscopy. Let's have a read through the question. Which pair of compounds would be difficult to distinguish using infrared spectroscopy? As we know, infrared spectroscopy is a method of analysis, and it gives you information about the types of bonds that are present in a molecule. For two compounds to be difficult to distinguish between using infrared spectroscopy, they need to have similar bonds, or even the same bonds. Therefore, to answer this question, we are looking for the option that only contains compounds from the same homologous series. If we look at all of the options, we see that option A contains butane and propane, which both belong to the alkane homologous series. Distinguishing between them would be difficult because they both contain only carbon-hydrogen and carbon-carbon bonds. Therefore, A is the correct answer.